Today we are going to do the conceptual problems of Coulomb's law. The first one, I am reading out the statement. Four charges are arranged at the corner of a square ABCD as shown in the figure. This is our square ABCD, and the charges plus Q, plus 2Q, plus Q and minus 2Q are placed at the corners of the square. Now, the question is the force on the charge is kept at the center O. Here, at the center O of the square, a test charge is being kept, and it have been asked how much force is experienced by this charge kept at the center O. And the options given are it may be 0, or it is along diagonal AC, or along diagonal BD, or it is perpendicular to the side AB. So these are the options given for the problem. Now at O, we want to find out the force, and the force will be given by the charges. So we will be applying Coulomb's law, because Coulomb's law is applicable for the force produced because of the charges. Now at O, we will see at B point, it is giving the force plus 2Q charge, plus Q charge is applying force on it, minus 2Q and plus Q. Now, if you look at the figure, you can see the force that is produced by A and produced by C. They are equal in magnitude but opposite in direction. So, along AC, along AC, the net force on A will be 0. Again, I am repeating why at point O the force is 0 because of A and C. Because at A and C the charges are equal in magnitude and opposite in direction, and at point O they are having the null effect. Now look at the other points B and D. They are having the charges, they are equal in magnitude, but their nature is opposite. It is minus 2Q charge, and that one is the plus 2Q charge. So here point O will experience the force because of B and D. Now what will be the direction? The direction will be, since it is a positive charge, so positive charge has got the tendency of outward direction, and minus 2Q, it has got the tendency of inward direction of force. Because of that, we will the point O will experience the force along the diagonal B towards D. So C option is correct. The force experienced by this point O will be along the diagonal BT. The second conceptual problem is a body can be negatively charged by giving excess of electrons to it, or by removing some electrons from it, or giving some protons to it, or the fourth option is removing some neutrons from it. So in my last video, I have discussed about the properties of electric charges. In that, I have mentioned that there are two types of charges. A body can be charged positively or negatively, but that will be only due to the movement of electrons. Protons won't participate in, neutrons won't be. So these options won't be taken for the body to be charged. Now, among these two options, giving excess of electrons or removing some electrons from it. See, when a neutral atom is there, and from there the electrons are being taken to the next body, then it will be having positive charge on it, because some of its electron, either will take an example, one electron is removed from it, so the electron that is being gained by the other body will have the negative charge on it, and the body that one is losing will have positive charge on it. So From these two options, the body that is gaining, when we give the excess of electrons to it, it will become negatively charged. So option A is the correct option for making a body negatively charged. Our third conceptual problem is two equal point charges, each of 3 microcoulomb, are separated by a certain distance in meters. If they are located at the position I cap plus j cap plus k cap and 2 I cap plus 3j cap plus 3k cap, then the electrostatic force between them is, and these are the four options given. So let us calculate the electrostatic force. We know the formula for the electrostatic force F is equal to. Now, because it is in meter, we will convert the charges also in the coulomb. So this is SI system. In SI system, we have 4 pi epsilon naught as the constant value, product of charges and square of distance between them. In my previous lectures, I have mentioned the force is given by this formula for SI system. Now, putting the values, F is equal to 9 into 10 power 9. Putting the values of pi and epsilon naught, we get this value 9 into 10 power 9. Now, the charges are 3 microcoulomb each. It means Q1 is equal to Q2 is equal to 3 into 10 power minus 6 coulomb. Here I have converted this micro into the value 10 power minus 6, putting that value, and this converted into coulomb. So this thing can be written as 3 into 10 power minus 6, 3 into 10 power minus 6. Now we are left with the distance between the two charges. Here we are having the positions of these two. Here, let the first position R1 is given by I plus J plus K cap, and R2 is given by 2I plus 3J plus 3K cap. So the distance between them, say R2 minus R1, is given by 2I plus 3J plus 3K. So this comes out I plus 2J plus 2K. Now the magnitude of this difference R2 minus R1 is given by, so this comes out to be under root 9, that is equal to 3. Now putting the value of the distance between two of them, that comes out 3 meter, we will write down 3 into 3. So it is clear from here that force comes out to be equal to, this cancels, and this is 10 power 9, this is 10 power minus 6 will become minus 12. So 9 into 10 power minus 3 will be the answer in newtons. So among these four, our option number B, that is giving force is equal to 9 into 10 power minus 3 newton, is the correct one. The next question is, if the distance between two equal point charges is doubled and their individual charges are also doubled, what would happen to the force between them? And the options are, force will become 2 times, force will remain same, force will become 4 times, or force will become 3 times. So let us calculate it. We have to find out the force. It is given by F is equal to 1 by 4 pi epsilon naught, product of the charges upon distance between two of them. Now you can see the conditions that have been given, these are two equal point charges. So Q1 is equal to Q2 is equal to say Q, and their individual charges are also doubled. What is being done? The distance between the two charges is doubled. In दोनों के बीच का जो distance है, that is doubled. It means R is has become 2R, and the individual charges are also doubled. These charges have been doubled, they have become 2Q. Now this is our equation number 1. In the equation, first we will find out the force according to the condition. 1 by 4 pi epsilon naught, since charges are equal, so Q square, and distance between them is the R square. This is the initial force that is lying. After making the charges double, these are the changes shown by the arrow according to the statement. Now the force is equal to 1 by changed force, let it be denoted by F dash, 4 pi epsilon naught. In place of Q, we will be writing down 2Q. 2Q into 2Q divided by, now according to the statement, distance also been doubled, so it is 2R square. Now we find it 1 upon 4 pi epsilon naught 4Q square over 4R square. 4 cancels with 4, and we can see the force that is initial 1 upon 4 pi epsilon naught Q square by R square, and the change force that is F dash is also 1 by 4 pi epsilon naught Q square by R square. So we find that there is no difference in the forces. The force remained the same if we have doubled the charges and also doubled the distance between them. So option force will remain same is the correct one, that is the C for this problem. Now the next conceptual problem. A charge Q is divided into two parts such that they repel each other with a maximum force when placed at a certain distance apart. How the charge has been divided? In this statement, it is being given that a charge is divided into two parts such that they are repelling each other with a maximum force, and we want to find out how that charge have been divided. So these are the options. 4 options are given. For the division of them, we have to find the correct one. Let the given charge is Q, that is divided into say Q dash. The other part will be Q minus Q dash. Now we'll be taking the force between them, that is 1 by 4 pi epsilon naught Q dash Q minus Q dash over R square, or this will become 1 by 4 pi epsilon naught Q dash Q minus Q dash square over R square. If we see that the force is maximum after the division, that they are repelling each other, that value of force is going to remain same. That is going to remain a constant value. For division of charge for maximum force of repulsion, under this condition, the value of F is going to remain constant. F will be constant. A one particular value of force will be there, it means. So our change with respect to the Q dash is going to become 0 for F constant. Using this condition in equation number 1, according to the statement, we have equation number 1 becomes After differentiating equation number 1, with respect to q dash, we have df dq dash equal to 0. It is now differentiating this part. R is a constant value, 1 by 4 pi epsilon naught r square q minus 2q dash, or from here we get q minus 2q dash is equal to 0, or q dash is equal to q by 2. So this is how the charge, that q dash is equal to exactly half of the charge. So this is how the division of the charge equal parts, it means, to be done to get the maximum force of repulsion on dividing them. So our option D, that is the charges must be divided into two equal parts, is the correct one.